let's take a look at that packet. And also coming back out to y'all is old homework. So grab yours and pass on the rest if you don't mind.
Easy to keep a grudge. How is it easy? But it's easier to let go of a grudge. Okay.
Wait.
I like holding on to grudges.
Huh.
What happened to brown?
All right, so let's flip back to the ones that I had wanted you to graph. Let's take a look at those, see how we do. So on that third page, maybe? Yeah, that third page, the very top one starts with y equals 2x squared plus 12x plus 20. And then it has the scribble that one on bottom. What kind of questions might you have come up with on any of those? Any of those you would like worked out? Yeah. The one that's negative 3x squared?
Yeah.
You got it. All right, so let's go here. Let's insert, no, let's go math, graph, Cartesian. So we're going to graph y equals negative 3x squared plus 18x minus 25. Okay, so we want the pattern graphing to work. Hey, quick question. When we're pattern graphing and I say, hey, fill out the table next to it, could you pattern graph and find the points that would go on the table? Gosh, I hope so. Because when you pattern graph, you find all of them. All right, so what's my go-to equation? Every time.
Negative b over 2 times a.
Thank you. Negative b over 2 times a. So let's identify a. My a value is negative 3. My b value is 18. And heck, let's not leave the c value out. We'll deal with more of the c value later. The c value actually, I don't know if you've started realizing this, the c value is actually where it crosses the y-axis. So this would cross at 0, negative 25, which is way off our grid, so we don't really worry about it all the time. All right, and this is going to find me my axis of symmetry, and it's also going to find me my x component of my vertex. So I'm going to get negative 18, because there's a negative there, and 18 is that, times 2 times negative 3. Do I have that plugged in correctly? Okay. Do a little arithmetic here. So I got negative 18 over negative 6. Agree with that? Negative over negative, we learned a long time ago, was positive. 18 over 6 is then 3. So my axis of symmetry, which we'll call AOS, is the vertical line x is equal to 3. So that's my axis of symmetry. Remember, that's the vertical line that I can fold over my vertex or my parabola on. My vertex will always fall on the axis of symmetry. How do I figure out the rest of, or the y value of my problem? What should I do with that 3? Plug it in. Okay. This is an x value, right? So I'm going to plug it in here and here. So I get 3 squared. That's 9. 9 times negative 3 is negative 27. Is that okay so far? Then 18 times 3 is 54. And then minus 25. So let's see. Negative 27 added to 54 should be positive 27, I believe. And then positive 27 added to negative 25, or 27 minus 25, is 2. So I find that 3, 2 is my vertex. Agree? Does this parabola open up or down? Does it open up or down? Down? Why?
Because it's negative.
Yeah, the a value is negative. So this dictates that it opens down. Okay? And then we know that our pattern graphing takes place with 1, 3, 5, but 1, 3, 5 is going to be modified a little bit. For what reason? The a value. So I need to take my a value, whatever my a value is, and multiply it. Well, my a value is negative 3, so it's going to go negative 3, negative 9, negative 15. So we'll clearly go off our graph pretty quickly. So I'm going to go right 1 down 3 and left 1 down 3. So this is the point 4 comma negative 1. This is the point 2 comma negative 1. Obviously my vertex, we already said, is 3 comma 2. Okay, so that works. And mine actually looked like I'd run out of space. If I wanted to go one more, I'd go right one and down 9. 1, 2, 3, 4, 6, 7, 8, 9. Oops. So like 9's down there and 1. So there's our parabola. Should go through that dot as well. Cool? What else from that first page that has the scribbled out on the very bottom would you like to see?
I have something on the second page.
Second page?
Yeah.
Ready to go to the very back page? Or the back page of it, where the very top equation is x squared minus 4x plus 3. The very bottom equation is y equals x squared minus 8x plus 15. So what on the second page? What do you got?
Y equals x squared minus 1.
X squared minus 1?
Yeah, that one.
Cool, thanks for asking for that one. Alright, this is graph, cohesion.
Wait, what are you doing? What page?
Y equals x squared minus 1. Okay. First off, does it open up or down?
Up.
Opens up. Are we missing a value? And if so, is it A, B, or C that we're missing?
B.
B. We're missing the B value, agreed? We don't have the x term. So just so you know, the x squared term is called the quadratic term. The x term is called the linear term. And then the number is called the constant. Okay? That's for free. You don't need to know that. All right, so I know that my go-to equation is negative b over 2a. But then we have my a value of 1. My b value is not there, so it's got to be 0. My c value is negative 1. Okay, so if my b value is 0, I get negative 0 over 2 times 1, which is 0. So my axis of symmetry is the equation x equals 0. So that's this. Agreed? And then my x component of my vertex is 0 comma something. What should I put? What should I do to get my y value? Plug it in. So 0 squared is 0. 0 minus 1 is negative 1. So I get 0, negative 1, which I guess is about here on my graph, right? Do you agree with that? Will my pattern graph of 1, 3, 5 work? Sure will. Okay, my a value here was 1, so that change it stays the same. So I'm going to go right 1 up 1, left 1 up 1. This was counting by 2, so that's what I would.
Wait. Can you explain the 1, 3, 5 thing?
Okay, this is the pattern graph that I'll always do, and your pattern graph will always be a times that. Well, my a value is 1, so it's always. In this case, it'll just be 1, 3, 5. The last one we did, we had an a value of negative 3, so we had to go negative 3, negative 9, negative 15.
Okay, so how do you plug that in?
All right, ready? So from my vertex, and realize I'm counting by 2's up here on mine, right? So I went right 1 up 1. So now that's the point 1 comma 1. And that's the point negative 1 comma 1. Is that okay so far? And I can keep going with this. We'll go red. So now I'm going to go to the 3. So from here, I'm going to go right 1 and up 3. 1, 2, 3. And again, because I'm counting by 2, and left 1 from here and go up 3. So this is the point 2 comma 3. And this is the point negative 2 comma 3. I could even go one more, I guess. So I can go right 1 and up 5. So from here, I'm going to go right 1 and up 5. 1, 2, 3, 4, 5. So that's the point 3 comma 8. And if I go left 1 and up 5, 1, 2, 3, 4, and 5, that gives me the value negative 2 comma 8. I got all kinds of values up here. There we go.
Wait, so what does the 135 do? Because
That's the pattern graph. So let's do it this way. Let me just pull up an arbitrary problem. Okay. So, and you can jot these notes down anywhere on that green packet. So let me insert a graph. Let's see, how big can I make it? That seems to be a pretty good one. Okay, so let's say we had y equals 3x squared plus 2x. No, that's not going to work. Plus 12x plus 1. So my a value is 3, my b value is 12, c value is 1. You okay with that? This opens up. You okay with that?
Yeah.
Okay. And of course, I made this one up off the cuff, so it's going to be some weird things. So I'm going to go negative b over 2a. That's what my x is equal to. So I get negative 12, because that's my b value. The negative comes along, times 2 times 3. So that's going to give me negative 12 over 6, which gives me negative 2. So x equals negative 2 is my axis of symmetry. We'll call that AOS. So axis of symmetry is right here. You okay with that?
Yeah.
And are you okay getting the rest of the vertex? So I'm going to say, I'm going to take this negative 2, I'm going to plug it in here and here. So negative 2 squared is negative 2 times negative 2, which is 4. 4 times 3 is 12. Minus 24, the reason it's minus 24 is 12 times negative 2 is negative 24 plus 1. So, shoot. I would have had to make this one a little bit bigger. Let's see, I'm going to erase that for now. I'm going to change my graph. That seems like a good one. Counting by 2s. Actually, I go even bigger. Let's take it up to 20s. Oh my gosh. So notice we're counting by 5s in each direction. Okay, so my vertex will be negative 2, comma, negative 12. Is that 11?
Yeah.
Negative 2 is like here, right? And then 11 is like right there. So that's my vertex at negative 2, negative 11, or positive 11. Remember, my axis of symmetry is this. Is that okay so far?
Yeah.
Okay, so now I have this 1, 3 characteristic on graphing. And we always start with 1, 3, 5. It's all the odd numbers. I mean, it keeps going 7 and then 9. It keeps going. But that would just get way too big. So I'm going to take whatever my a value is and multiply it times all those. So 3 times 1 is 3. 3 times 3 is 9. 3 times 5 is 15. So it's growing upward. Right 1 up 3, right, and then from that point, right 1 up 9. So we're only going to get 1 extra point here. So I'm going to go right 1 up right 1. I'm off someplace. Negative b over 2a, so negative 12. That's a negative 2. Negative 2 plugged in, so 12. That's a negative 11, isn't it? My goodness, I tell you, you guys can't take me anywhere.
No better.
Alright, let's just bust out the eraser here. I'll need that. That would have been wrong. Okay? Alright, so now I've adjusted the vertex. So now it's going to, from there, we're going to graph that quickly. So from here, I'm going to go right 1 and up 3. 1, 2, 3. Okay? And then I'm going to go left 1, up 1, 2, 3. And that actually doesn't fall right on that axis, does it?
Well, where are you getting the coordinates to do that?
Okay. So watch. I'm going to go from my vertex, so at negative 2, I'm going to go right 1. So if I go right 1 from negative 2, I get to negative 1. If I go left 1 from negative 2, I get to negative 3. Okay. My first move, I'm going to go from my vertex up 3. So 11 up 3 means I get to 8 and 8. So -1, 8. It's like right there. And then right there. Okay, so that's what these points are. And then from there, I'm going to go from those points, right 1 up 9. So I'm going to go right 1 up 9. That takes me to this +1. And that goes to -4. So this point right here is the point 0, 1. And this is the point -4, 1. So this is a real skinny parabola as far as this graph is concerned. And that's how I got those points. Okay, it's always going to be right 1 or left 1 from the new point. And then it's going to go up however much the ratio of the pattern is. What else from that green sheet would you like to see? Yeah?
How do you get, like, how much numbers go up? Like, the 3,
So-
9, and the 15, where does that come from?
So you start with the 135, and it's times the A value.
Okay.
So the A value is 3, so I change it to 3, 9, 15 because 3 times each of those numbers.
Okay.
But it still goes right 1 and left 1.
Yeah.
Yeah.
So I still don't understand the 3, 9, 15. Like, where does that go? Like, no,
Am I
no,
talking to my wife? All right.
no, I know.
All right, ready?
It's not the same question.
So this
No.
is always going to be the same. That's our starting point. And we're going to take my A value and multiply it times that. That's where this comes
Yeah,
from.
I know that, but where do the 3, 9, and 15 go on the graph?
That's how much we go up or down. So we will always go right and left 1, and then right and left 1, and then right and left 1 from our new points. But on this one, I'm going to go right 1 and up 3.
Okay.
And then from that new point, I'm going to go right 1 and up 9. And then from that new point, I'd go right 1 and up 15 if our graph allowed it. Cool. All right. We good? Okay, so put that away. That's kind of notes that you can hang on to. And I'm not a big fan of pop quizzes, so we're not going to call this a pop quiz. This is going to be an opportunity that you can have, let's try about 5 minutes on, and then we're going to go over it. I will not collect it as a quiz. Did you have something for Monday?
Or it was like last night on Monday.
I'll do that next. There you go. Thank you. Can I text you?
Oh, yeah.
Okay. Huh? One more? Okay.
Anyone else want to go on? Or like a conversation time?
So try this. Take about 5 minutes to try it on your own. I would say use the 135 method on the first one and then fill out the table accordingly. got 3 minutes.
For one or for all of them?
Get them all. Dude, we got everyone here today. Someone should get cupcakes or something for us.
I'm about the appetizer.
Yeah, buddy. About a minute. Dude, I'm not done yet. I know. I'm not clicking.
What is domain mean again?
Well, domain on these is nice because it's always negative to positive infinity. So it's going forever left and right.
Oh yeah.
The range is where it starts. So if it's opening up, it's your lowest point to infinity. If it's opening down, it's your highest point to negative infinity, or negative infinity is your highest point.
Okay.
Clarice doing all right back there?
Yeah.
Yeah, buddy. All right, let's go through it, see how we do. This one we wanted to fill out the table. So my go-to every time, negative b over 2a. And it looks like my a value is 2, my b value is 8, and my c value is also 8. Agreed?
Mm-hmm.
So I have negative 8 over 2 times 2. So that's negative 8 over 4, which is going to give me negative 2. So my axis of symmetry is going to give me negative 2. X equals that. Okay, and that's also the x component of my vertex. X equals negative 2 is right here. So again, that's the mirror. Then I could fold it over. It becomes symmetric. So if I wanted to find the y component of my vertex, I have negative 2 here. So what should I do? Plug it in. All right, so I'm going to plug negative 2 in here. So negative 2 squared is 4. 4 times 2 is 8. Agree? And then plug negative 2 in right here. 8 times negative 2 is negative 16 plus 8. So 8 minus 16 is negative 8. Negative 8 plus 8 is 0. So 2, 0. So it's sitting right there. Agreed? Anyone problems with that? So that's 2, 0. Now we're going to fill out our table, but we're also going to pattern graph at the same time. Pattern graph is such a valuable tool my pattern graph will go as 1, 3, 5, but I have to multiply it by the 2. So I'm going to get 2, 6, 10. Is that okay? Does everyone see where that came from? All right, so let's pattern graph. A number to the right of -2 is -1. Number to the left is -3. Okay, so I'm going to go right 1 up 2, left 1 up 2. Oh, okay, so that gave me a 2 and a 2. Agree with that? Table filling out okay? I think so. All right, let's go orange. A number to the right of -1 is 0. Number to the left of this is -4. See how it's symmetric about that? So you added 1, subtracted 1, added 1, subtracted 1. All right, so my pattern graph, I'm going to go up 6. I'm going to go right and then 2, 4, 6. 2, 4, 6. So that's going to give me 0, 8 and -4, 8. We just filled the whole thing out. All right, it says find the vertex. We have it. Find the axis of symmetry. We have that. X equals -2. Find the y-intercept. This right here is the y-intercept. That's at 0, 8. Okay, the y-intercept is always 0, c. What's my c value? 8. So does that make sense? All right. And what is the domain on this one? So it's going to go forever this way and forever this way. So my domain for all my parabolas I'll use in Algebra 1 will go from negative to positive infinity. The range is going to switch up on you, but we didn't ask for that. That's the first problem. Agree? Move on to number 2. Okay, problem number 2. They just want us to pattern graph. So my A value is going to be 1, my B value is -6, my C value is 1. I'm going to use x equals -b over 2a, which is -6 over 2 times 1, which is -6, +6 over 2. So x equals 3. That's my axis of symmetry. Okay, so my x component of my vertex is going to be 3, something. How do I find something? Plug it in. So I get 3 squared, that's 9. -6 times 3 is -18 plus 1. 9 minus 18, -9. -9 added to 1. -9 added to 1 is -8. Did I do that right? So 3 is right there. -8 is down here. Does this parabola open up or down? Up. Okay. Is my pattern graph going to be 1, 3, 5 or is it different? It's 1, 3, 5. Everyone agree? Why does it stay 1, 3, 5? Because my A value is 1. Okay, so I'm going to go from this point, I'm going to go right 1, up 1, and mine's counted by 2's. Okay, so that's going to be the point 4, -7, and that's going to be the point 2, -7. What do I do next from those points? What do I do next from those points to get my next set of points? Right 1, left 1, up how many? 3. So I'm going to go right 1 and up 1, 2, 3. I'm going to go left 1, up 1, 2, 3. So that's going to give me the point 5, -4. And that's going to give me the point 1, -4. Heck, I can keep going on this one because I got plenty of room. So from those green dots, what would I do? Right 1 and up how much? 5. Good. So I'm going to go right 1 and up 5. 1, 2, 3, 4, 5. And left 1 up 5. Hey, what did I just find right there? Y-intercept. The y-intercept is 0, c, right? So 0, c. Is that the point 0, 1? Yep. And that's the point 6, 1. And there's my parabola. All right. So find the vertex. We got it. Vertex is right here. Find my axis of symmetry. Got it. It's right here. Find the y-intercept. Got it. It's right there. And then where, oh, this is one of those, where's it increasing? What did increasing mean?
Positive slope.
Yeah, you'd have a positive slope. So right over here, starting at the vertex, not including it, where I made it black, if I picked any of these sets of points and I found the slope, I mean, seriously, like y2 minus y1 over x2 minus x1, if I found that, I get a positive number. So it's increasing. We're going to talk about the x direction where it's increasing. Well, if it's increasing starting at the slope, it's starting at 3. It's a round bracket because exactly at 3, the slope is actually 0. And then going to that way to infinity. So it's increasing from 3 to infinity. Cool. All right. This one says to factor it. We're not solving it. So this one should factor at x minus 5, x minus 2. Done. Okay, yes, you could do our fast way if you wanted to, but that's the quicker way. Last one. This one I would do, I'll multiply that times that, I'll get 6. The factors of 6 are 1 and 6 and 2 and 3. Everything's positive, so I'm going to go 2x squared plus 1x plus 6x plus 3 because I want 1x and 6x to give me 7x. Factor out an x on my first 2, and that gives me 2x plus 1 plus 3, and then that's 2x plus 1. So then I get 2x plus 1 and x plus 3. Done. Cool. There you go. That's for you. Keep that. That's kind of notes for today a little bit. And then let's see. These will go through a little quicker. I'm not going to cover all these because we're running out of time. But how does that quiz feel? Is it stuff you've seen before? I hope so. So I kind of taught it. If you don't believe me, the videos document that I taught it at some point. You guys want to hear a silly? So my freshman daughter, her name's May. She is taking honors geometry at Arapahoe High School. Kind of makes sense being that you need one more?
No.
So it kind of makes sense that kid of a math teacher should be in an honors class. But so they were learning something called trigonometry, and they were using something called a unit circle, which I taught 2 weeks ago in my accelerated algebra 2. So my daughter and like 5 of her friends are hovering around her computer, and they're watching the video of me teaching. Thank you. And their teacher comes back going, "Put that away, you should be watching that." You gotta love the wittiness of my daughter. She's gonna get her butt in trouble one day, but still love her. She just says, "You're just jealous because my dad's a better teacher than you." Oh. Thanks, kid. All right.
Pure facts.
All right, so let's see. A is 1, B is -2, C is at -8. Hey, did everyone get a copy of the notes? Good. So we're going to go -b over 2a. That's going to get us the axis of symmetry. So I'm going to get -2 over 2 times 1. So that's going to be 2 over 2, which is just 1. So my axis of symmetry is x equals 1. Agree? So that's right here. It's not a crooked line, but I've been sniffing glue, so it's a little wiggly. All right. So the x component of my vertex is 1. How do I find the y component of my vertex? Plug it in. 1 squared, 1. -2 times 1 is -2 minus 8. 1 minus 2 is -1. -1 minus 8 is -9. So 1 -9 is way down here. That's my vertex. So 1 -9. Okay. Hey, can I find the y-intercept without doing any further? Yeah, it's my c value, right? So 0, comma c. So 0, comma what? -8. Cool. Oh, and they don't want us to pattern graph. It looks like they want us to find us the roots. So that means I want to factor this now. So I'm going to take x squared minus 2x minus 8. Okay. The numbers that multiply together give me -8. Add together to give me -2. So I have -4 and +2. And I set those equal to 0. So I get x equals 4. So I have a root at 4, comma 0. and x equals -2, so that gives me -2, 0. So 4 zeros right here, -2 zeros here. So we didn't really pattern graph out this. We actually used our roots because it was factorable. But of course, you could say this. You could do this on this problem. Well, I'm going to go right one up 1, left one up 1, right one up 3, left one up 3, right one up 5. It worked. I like that. And just by looking at those points established on your graph, you can see where it crosses the where it crosses the x-axis in this case. It's kind of cool. Cool? All right. Intercept form, that means we can factor it. Blank page for some reason. Okay? A student claims these two functions will make the exact same graph. Why does the student claim that? Well, if I multiplied this whole thing out, I'd get x squared minus 4x plus 2x minus 8. Combine those together, I get -2x there. Yeah, they're the same. So this one's in its factored form, this one's not. Okay? Ooh, let's see what we got here. We got stars. So you can copy these down. That's just telling you what we had done with it. Did Mrs. Hogue work out all 6 problems on the homework from Monday? Yeah. Cool. So why don't I just do this? Do me a favor. Page 64, you put a 4 on the top of it. I'll make sure I put it in the grade book. While you're copying that down, so that was page 63, 64. Please, 63, 64. Come on, baby.
I think mine was that one. Too bad. See what it looks like.
Done? Got that? So real quick, while you're cleaning up, you still got time. Still got time. So any of these, whoops. Freeze. Anytime it's already factored out, this tells you that at 4, 0, you have a root. This tells you at -2, 0, you have a root. So what happens halfway in between my roots? What do you think would happen halfway in between my roots? The vertex. So halfway between -2 and 4, we'll just come in. There's one, I come in another. Oh, somewhere here at 1, and if I plug 1 in, 1 minus 4 is -3. 1 plus 2 is 3, so -9. So your homework is going to be page 65. And let's just do this for page 65. What do you say we do the odds? It's only one page. Well, it's page 65 and page 66. Page 66 is a blank sheet. Get out of here, guys and girls. Have a great day. Take care of one another.